If you're hearing some background noise, that's because I'm recording this in a hotel hallway. So bear with me. With the ice storm, we haven't had power for a few days. So yeah, we'll just get right into this because that's going to be old news here in a minute. Okay, so the distance formula. This is section 1.3. Make sure you can review it in your book as well. So if we've got A, which is at the first x point and the first y point, and a point B, which is at a second place, a second x coordinate and a second y coordinate. They are points in a coordinate plane, then the distance between the two is, so this is the distance between A, B, and really we're just talking about length, right? So this is the formula. AB equals the square root of all the things. Square root of what? Parentheses, x2 minus x1 squared plus y2 minus y1 squared. Now, some of you are looking a little bit like this right now on the inside. Don't freak out. Let's go through it. The distance formula is really just, it's a ruler for two dimensions. It's the Pythagorean theorem, which you already used in middle school. So let's review how that works. So we've got an x coordinate, an x distance, right? How far does it go side to side? And we have a y distance, which is b. How far up and down does it go? And so that's all. So the horizontal distance, how far side to side it goes, is the length of A. That's the x2 minus the x1, but it's always positive, right? Well, how do we make it always positive? Well, squaring it and then square rooting it will make sure it's always positive. So that's why we have the squares and the square roots. So the length of the side-to-side movement is just the second point minus the first point for the x-coordinates. And the length of the up and down is how far you have to go to get from the second point to the first point just vertically, right? And so there's absolute values around that to make sure it stays positive. So it's x2 minus x1 for the side-to-side, but it's a positive distance. It's y2 minus y1 for the up and down, but it's a positive distance because distance is never negative, right? Distance is never negative. And that's what this is talking about. A negative times a negative is always a positive, which is why we're squaring things. So here's our Pythagorean theorem. We know that the A, the side-to-side movement, is just the second point minus the first point, as far as side-to-side. Second point minus the first point for its up and down. We're going to square it. And everything is still squared because it's Pythagorean theorem. Now we're just going to square root both sides. Square roots and squares, if you'll remember during middle school and last year in Algebra 1, square roots and squares are equal and opposite, just like adding and subtracting are equal and opposite. So we've got our c squared, we square root it, both the square root and the square goes away, and we're just left with the distance. What we do to one side, we must do to the other, right? So we're square rooting both sides, so this is what square rooting both sides looks like. And this is how we get the distance formula. So the distance formula is really just the Pythagorean theorem. It just looks a little different. So don't freak out. Some of you are still freaking out. So let's step through an example, okay? Let's find the distance between 1, 2, so it goes over 1 and up 2, because with coordinate pairs, the first part of the coordinate pair is always the x part, the side-to-side part, right? And then the second part is always the y part, the up and down part. So 1, 2, here's A, and B, which is at -3, -2. Let's take a look. -3, backwards 3, -2, down 2. So here's B. Well, what's the distance? Well, can we make a triangle out of it? Well, sure. So we could use the Pythagorean theorem on it. How far is the side-to-side movement? How far is the up and down movement? And that'll give us, when we plug it into our formula, our distance. Even though we don't have a grid where we can perfectly count them, we can still know the distance. So let's do it. The second x minus the first x. Well, where is the second x? It doesn't matter if your 1 is your second x or if your -3 is your second x, but make sure that it's the first part of the coordinate pair that's your x's. So we're going to use -3 minus 1. -3 minus 1. Those are my x's, right? They're coming first. Second part, we're going to put those in parentheses, square it, plus, here's my second part in parentheses, negative 2, because that's my y2, that's my second y, minus, well, what's y1? Well, let's take a look. It's positive 2. So negative 2 minus that positive 2. We don't have to put the plus there, right? So negative 2 minus 2, we're going to square that. And then once that's all done, then we'll square root it. So let's do what's in parentheses first, because order of operations, negative 3 minus 1 is negative 4. Negative 2 minus 2 is negative 4. If we square those, we get positive 16s. So you should never have a negative distance. We get positive 16s. If you're doing this in a calculator, make sure that you're putting the negatives in parentheses before you square them. 16 plus 16 is 32, and the square root of 32 is about 5.66. So that's what these wavy equal signs mean. That means approximately. So when you're doing this, if you get a radical form, so if you just get told that it's the square root of 32 on your calculator, you can just write down the square root of 32 as your answer. If your calculator tells you that the square root of 32 is 5.66, 5.666666, you can write that down. This looks like it's probably not that, but it's about that. Make sure and round to the second decimal place, okay? And that's all it is. So we're doing the second x minus the first x. We're squaring that. And then plus the second y minus the first y. And then we're squaring that. Deal with your order of operations, and at the very end, you can try and square root it. And that's the distance formula in a nutshell.